You can feel the positions of chloride ions and sodium ions in this unit cell with the help of a model in my hand. Look here, in this model the colorless balls represent chloride ions. So as we have read, these chloride ions are constituting FCC unit cell, and all the sodium ions which are represented by blue balls are occupying octahedral holes. You have already noted that each edge center is an octahedral hole. So you are finding there is a sodium ion at this edge center, sodium ion at another edge center, and in this manner all the edge centers are occupied by sodium ions. Plus one sodium ion is present at the center of symmetry of this unit cell. That is deep buried in this figure, in this model. If possible, you may just look. I would try to show you a blue ball present at the center of this mini cube. That is another octahedral hole which is not shared by any other cube. It is exclusively belonging to this unit cell. In this manner, this becomes a model for sodium chloride structure. One thing more I would like to tell you. Look here, this is the edge length A, and that is equal to 2 times R plus R minus. So the formula that we have already noted is visible over here. H length is equal to 2 times R plus R minus. Number 2, zinc blend, that is ZnS, zinc sulfide structure. Here sulfide ions are supposed to be forming a FCC unit cell, and zinc ions are occupying half of the alternate T holes in it. Therefore, number of sulfide ions per unit cell is equal to 4, and number of zinc ions per unit cell will also be equal to 4. Thus the charge is balanced, and the formula type is AB. Number of molecules or formula unit, capital N, per unit cell will be equal to 4. Since the coordination number of zinc ion is equal to 4, as it is occupying a T hole, therefore coordination number of sulfide ions must also be equal to 4. Hence it can be called as 4:4 coordination compound. Again, from calculation point of view, the important points are root 3a is equal to 4 times R plus R minus, because cube diagonal of a mini cube is root 3a by 4, and that is equal to R plus R minus. Further, density D is equal to N upon Na into M upon A cube. Put N equal to 4 and M equal to molecular weight. The other examples are CuCl, CuBr, etc. Number 3, fluorite CaF2 structure. This structure can be visualized by imagining that a FCC unit cell is formed by calcium ions, and fluoride ions occupy all the tetrahedral holes in it. Therefore, number of calcium ions per unit cell is equal to 4. Number of fluoride ions per unit cell will of course be 8. Thus the charge is balanced, and the formula becomes of AB2 type. Number of molecules or formula unit N per unit cell will be equal to 4. Coordination number of chloride ion will be equal to 4 because it is occupying a tetrahedral hole, and therefore the coordination number of calcium ion will be equal to 8. By using the formula coordination number of cation upon coordination number of anion is equal to valency of cation upon valency of anion. This formula we have already read. Hence it can be termed as 8:4 coordination compound. Again, the two important things which you should not forget for calculation, they are 2 times R plus plus R minus is equal to root 3A upon 2, and density D is equal to N upon Na into M upon A cube. Put N equal to 4 and M means molecular weight of the compound under consideration.